Okay, we've reached the end, the last of data representation, and the last lesson for this term really, or it might just stretch over the half-term break. Uh, but we're now looking at something called compression. We take pictures or we video things, and really we're not interested in compression, and we rarely do it ourselves. But the file types that we use indicate that we're compressing something, and it might be a bit of a shame if you are really trying to capture a great deal of information and you save it as the wrong file type. So you do need to know this, and the only time you really are actively involved in compression is if you are zipping or unzipping something. Uh, so other than that, it's just basically file types. So we need to find out why we need to compress things, and we also need to look at the kinds of compression that are available, and there are two. One is called lossy and one is called lossless, and hopefully during this video I'm going to explain what those two things are. So what is compression? Really, when we capture something, we may capture information in that file which is absolutely huge and maybe not even of any interest to us. I know that I take images with my camera, and their natural form is a TIFF file, which captures information for editing the picture, changing the hue, changing the saturation, changing lots of things. So the file tends to be incredibly large, and if I try to display that on a screen, well, it would work, but it's kind of pointless. Most of that information is missing. It's better off if I sort of edit the file and then save it as a JPG, much smaller, but keeping some information that I want that is relevant. So I need the picture, I need to see what it is, but perhaps I'm not interested in some of the background information that's presented in the file. I know it contains information for a printer, so the colours that you see on a printer are much different to the colours you see on a screen, so it's got that information. But if I'm showing something on a screen, I don't need that, so that can be gone. So I can make my file as small as possible. So for example, I might want to take a 30 megabyte file and reduce it down to 3 megabytes. So that's an image I take on my camera, 30 megabytes, but when I save it as a JPG, it's actually 3 megabytes on the computer, and we saw a little bit of that in the last lesson. So why do we need to do it? What's the point of compressing things? Well, smaller files, they take up less storage space on a device. I know one of my computers now is really struggling for space on the hard drive, so I don't want to be storing lots of videos in uncompressed state. I need to zip lots of things up to give myself some space on that drive. It is actually slowing the computer down, so smaller files will be useful to me. But I don't want to lose a lot of information either. Making them smaller doesn't mean I've got to lose information. We saw in the last video that when I took a video of 5 minutes in duration, it was around about 14 gigabytes, and to stream that on the internet with internet speeds that we have, the bandwidth, that would take about 38 minutes to play a 5-minute video. You get a lot of lag and a lot of buffering, a lot of stopping. So we need to sort of compress it, reduce the file size so that it can stream in real time. So 5 minutes worth of video would download in 5 minutes, not 38. So there's a good use for compression over the internet. And it's mainly the internet where compression is used these days. If we compress the files, we can also allow web pages to load more quickly in web browsers, simply because the information is traveling over the internet. And if you've got lots of images and lots of videos in your web pages, then we need that compressed so that it can be sent to you at a decent speed, rather than, again, the 38 minutes waiting for a 5-minute video to download. we need to get a web page on the screen as soon as possible. If you don't get that, then you lose interest and you click away from the site. Another good use for compression is email. I don't know whether you've ever noticed it, but if you try to send an image to a friend, it'll ask you, do you want to send it in small size, large size, original size? It'll give you the options on the sizes that you can actually send it. Normally when they open it up at the other end, they wouldn't be able to tell whether it has been sent in small, medium or large sizes. It would just look normal to them. But a lot of email suppliers who you get your service from will say, I'm sorry, you can't send an image or a file that's more than 2 megabytes. So whatever you're sending has to be reduced or compressed to below that 2 megabytes to be sent. Otherwise it will just be rejected by the email service. So we've got a lot of need for compression, and there's a lot of pros and cons, which we'll see at the end as well, why we should use it and why we shouldn't. So let's take a look at what lossy compression is. This is really important in red there. It permanently removes data from the file. Now you might think, oh, well, if I'm removing data, I'm going to lose all of the information in the file. Well, that's not quite true. As I said before, some of the information in a file is not actually needed by you. So that could be removed, or we could sort of remove some data without really affecting much of the file, and that's what I'm going to look at now. If we have lossy compression, what happens is that the file is smaller temporarily. So in other words, we shrink it down while we send it, and when we get it at the other end, we decompress it and restore it to its original state. So it's only shrunk down whilst it's being transmitted, or maybe saved, but mainly transmitted. It is temporarily, and it's lossless. So in other words, when we get it back on the screen, it's in its original form, and that's the point of the videos as well. We shrink those down, but when you receive it on your computer, it's expanded again so that you can see the whole video. So, as I said, we're going to look at this as an image. We've dealt with images, we know all this bit depth and width and height, but I want to take a look at the colour, and we dealt with colour briefly in the last video as well. And I'm going to look at lossy colour. So, we've learned about hexadecimal, and we've learned that this number here, F4, 2E, B8, is a 24-bit colour. There's 1, 2, 3, 4, 5, 6 digits there, and each of those digits is a nibble, which is 4 bits. So 6 times 4 is 24. There's 24 bits there. And if we split them down into their channels, I get the red channel being F4, the green channel being 2E, and the blue channel being B8. Now, going back to when we were playing with binary, we had something called the most significant bit and the least significant bit. Now, the most significant bit was the important part. The least significant was not really important at all. And that happens with all numbers. So, if we're looking at the number 11, the 10 is the important part, the 1 is the very small part, not really important. We've got the same here. So in red, I've highlighted the significant parts, the F, the 2 and the B. And if I sort of just represent my colour, just using the most significant bits, the nibbles that are most significant, I would get F2B. So I would have reduced the amount of colour from 24 bits down to 12 bits. I would have halved my file size. Unfortunately, I will lose all this information, the 4, the E and the 8. All of that information will be lost. I can sort of have a guess at what it was, but that could have been F5, F6, FF. I don't really know, so I can't build it back. Once I've stripped out this data here, I'm stuck. I've lost information. But does it really matter? I mean, this colour as 24 bits is great, This colour is 12 bits. Is there any difference? Well, let's take a look. Here's a web page that I created. On the left hand side, if we split the page down the middle, on the left hand side I've got the full, and I've underlined it here, the full 6-digit hexadecimal number, or a whole byte for red, whole byte for green, whole byte for blue, and I've used the numbers that we had in the last slide. So this is F4, 2E, B8, and we get this nice shade of pink here. On the right hand side I have compressed this information. So here's my colour here underlined, and I've got minimum there to show that it's the least. It's been compressed, and I've now got the hexadecimal value F2B. So I've taken just the most significant part of the red, the green and the blue and placed it. And if you notice that the colour is almost the same, you can probably just about see that this may be a little darker than this one, but for all intents and purposes it's the same colour. So I can shrink my file size down, so from having 24-bit colour down to 12 bits, half the size, I can still represent the same colour. However, if I did that with my images and lots of colour, I would tend to notice the difference. If I was taking a scenery picture and I was looking at the sky, instead of it being a smooth blue with clouds, I'd probably have bands of colour, and I'd be able to see the difference between the bands. So you have to be pretty careful when shrinking it, because you are losing information that you cannot put back in. So one other thing, we've got PNG files, or if you use Photoshop or TIFF files, they probably contain the alpha channel, which is transparency. So I've got red, green, blue and an alpha channel. Well, I don't really need the alpha channel a lot of the time. Sometimes you see images that if I placed it over this text, you'll be able to see through the image to the text. But if I get rid of this alpha channel, so there's no transparency, it would be a full white block and I wouldn't be able to see through to the text. But I'd still keep the picture. So I could remove the alpha channel, just giving me RGB in large PNG files, but I would lose it completely. I couldn't even guess at how much transparency was in the original picture. But I've reduced the size of the file. Then I could reduce this further by, instead of having a full byte for the red and green and blue, I could use the nibble that I've just shown you to get the same colour. So I'm reducing 32 bits of information from being red, green, blue and alpha, and we can see that here, down to just 12 bits. I've got the same picture. It's showing me the same information, but I've really compacted that as a file size. So that is 20 bits off per pixel. That's an amazing amount of information, but it is lost completely. It cannot be retrieved. Lossless data, so if I don't want to lose information, I need an algorithm, a method of actually shrinking the file. Now, we've seen this kind of information when we looked at the hex editor. I've got an example here, F4, F4, FF, 2A, 00000, or just 8 bytes per row. And I'm going to compress this. So my original data here is 16 bytes. I've got 16 bytes here. And I'm going to compress this so that I don't lose any data. And the way that I'm going to do it is count up the amount of items that I've got. So here I've got F4 and I've got it twice. Then I've got one FF, then I've got one 2A, then I've got 1, 2, 3, 4, 5, 6 zeros, then I've got 4 FFs and 2 1As. And I'm going to use that information as my algorithm to actually compact this. So this is how I would compress it. Now, when I compress a file using lossless data, it does shrink, but it doesn't shrink as much as a lossy data file. The previous one, we were losing 20 out of 32 bits. Here we're only losing a couple of bytes, but it is shrinking so that I can probably send it over the internet and rebuild it. So this is what's happened. I've got 02, which stands for the amount of F4s, so I can rebuild that. Then I've got 1 FF, then 1 2A, then 6 00s, and then 4 FFs and 2 1As. And that is a compressed file. So I've used the information of repeating values to build a compressed file, and I've reduced it. But the nice part about this, it's lossless, because I can rebuild the original. I know I've got 2 F4s, I know I've got 1 FF, 1 2A, 6 00s, followed by 4 FFs, followed by 2 1As, and so I can rebuild or decompress the data and get back exactly the original file that I had. In other words, I've lost no data. Going back to the previous video as well, we got a video that we were thinking about. 14 gigabytes for 5 minutes is quite a lot. Well, how on earth do they compress that data? So I'm going to do it via cartoon style, because it's a little bit difficult looking at this to show you how it's done, but you can come back and see it for yourself. Let's imagine that this is my original video. I've got one frame here, and then I've got a following frame here. That's 2 frames of my video, and what's happening really is just that the smoke is rising out of the chimney. So the way a video is sort of compressed is it takes the original image, so I've shown that below, and then the following ones only show what is different. So the only difference between these two, so it's like playing spot the difference, the only difference between these two is that tiny little cloud emanating from the chimney. And so that's the only data that I record. So I keep that as my main image, and then everything from it that changes tiny little bit, that's what I actually store. So this would be a whole image, quite large, and this would be a tiny little image with data on where it was placed. So the metadata would say where it went, and in that way I can compress my video just by recording only the changes from one frame to the next. So that's video compression of a sort. It is very complicated, and they use stunning algorithms. I could not even begin to program the algorithms that they use, but it works. So we get rather large videos, such as the one that you're listening to, being transmitted in real time. So that's some good compression going on there. So we're pretty much at the end now. We got some pros and cons. At the top I've got lossy in the dark blue. I'm going to go through them quickly. I'll make all of this available to you at some point for revision. So lossy, the good parts about lossy files is that they can greatly reduce the file size. You know, I can get 30 megabytes really down into 3 megabytes, meaning that I can store more files on my device. So if I've got a phone with songs, I can get more songs on there just by using a lossy compression. It takes up less bandwidth. Well, the files are smaller, and bandwidth is basically how fast they can be transmitted. So it doesn't need as much speed, so to speak, so that they can be sent to you, downloaded or streamed a lot quicker because they're smaller. They're commonly used as well. Lots of software can read lossy files. I've mentioned a camera several times. They tend to take pictures straight away into a lossy format. You really have to insist that your camera takes a loss, well, the full size, no data lost, if you want to work on editing your images in programs like Photoshop. The bad parts about lossy compression is that it loses data, and we can't turn it back into the original file whatsoever. Now, in a lot of cases that doesn't really matter. I've just shown you that the colours, one pink to another pink with lossy data, didn't change the colour that much. You'd have to be a genius to spot the difference really. But if we got text files or software apps that you download, we can't sort of lose data from them. If we lose data, then they make no sense. So a text file, you wouldn't be able to read it. Maybe if you think of a sentence, we only keep the vowels. That's one way of shrinking it down. Well, if you only keep the vowels, you've got no idea what the words were to begin with. Software, it needs every instruction, every step to be able to play the program back and make it work. So if you start taking instructions out, then well, you've lost, the program just isn't going to work, it's going to crash. So software, we can't use that lossy compression on software or text. If we have lossy files, they are worse quality than the original. Again, going back to those colours, you might not be able to spot the difference, but when you print out a picture, it's going to be awful. It's going to be terrible quality than the original one that you captured. But sometimes it's unnoticeable, as you saw with the pinks. You might not be able to tell the difference. Lossless. The pros on lossless. Data is only removed temporarily, so there is absolutely no reduction in quality. So you shrink it, you transmit it, you expand it again, and you've got the full quality. When we expand them, we actually call it decompressing. So zip files, if you archive or try to gain some space on your hard drive using a zip file, that would be a lossless compression, because that also works on text and software on programs. So it shrinks them down to give you more disk space. Doesn't shrink a lot, but shrinks enough to give you more disk space, but they can be decompressed, and lossless compression can be used on text and software files because they will rebuild back to the original. Cons with lossless files is, well, you only get a slight reduction in file size. If you remember back to the bytes that I was shrinking, I went from 16 down to 12 bytes. That was only a 4-byte reduction. It wasn't a great deal of space that I gained. However, it was a small amount of space. So if I was trying to get a song from the internet, and I downloaded it and it was compressed, if it was in a lossless compression, the file size that comes through might be around about 30 megabytes. But if I had that very same song and used lossy compression, in other words, I lost some of the sample size, so I went from 24-bit sample size down to 16-bit. In other words, I lost some of the quieter sounds, or I had a sample size, instead of having 44.1 kilohertz, I sampled that at 15 kilohertz. I may be able to get that song down at 5 megabytes, the very same song, but it would be a little bit tinny, and I wouldn't hear the quieter stuff. So there's trade-offs there. Some file types, we looked at some file types in the last lesson, but basically lossy compression is MP3 audio. And we could go into MP3 a bit more, and we might do later on if we have the time, on how it works. But that's the one that really affects you the most, MP3. AAC audio, AIFF audio, you probably won't use, depends on the computer system you're using. But a JPEG image, well, JPG is exactly the same as that. That is a lossy compression, so it loses alpha channels, it loses colour. And that is a very common one that you use. For lossless, FLAC for audio, you would hardly ever come across that one. TIFF images and PNG images. TIFF images you might not come across. They're probably the best images, the best quality images, they really contain a lot of information. They're probably in digital cameras when they take the original picture, but like I said, you'd have to set your camera up to take it. And PNG images, they're probably the ones that you work with on computers these days, with transparent backgrounds and lots of colour. Normally you start off in Photoshop with a PNG image, and then you store your PNG image on your computer, but if you want to put it into a web page, you would probably turn it into a JPEG. So you've got the same kind of image, the same picture, but greatly reduced. So that's the end of data representation. There's a simple question that I've asked you. When I say simple, you just got to give me some reasons why we're using something. Lossy over lossless compression. When we come back, we will go over anything that you don't understand, particularly in the binary section, before moving on to the next topic.